For acceleration in 2D, we're treating them a little bit like a projectile motion question in that we're going to look what's happening in the x direction, what's happening in the y direction. Okay, so in this question, we've got a car traveling. Actually, let me just put this little northeast southwest thing here, because we're going to get some directions in here. Car is traveling 27 meters per second, south 25 west. Okay, so here is straight south. Here is south 25 west. Yeah, so we're kind of going somewhere over this way, 25 degrees. So the car enters the corner going this way. It's going to speed up, so its speed increases from 27 to 31, but it ends up going west 10 degrees south. Okay, so this is kind of a curve, and if you can picture straight west here, we're going, let's try to make this look a little bit, yeah, a little bit believable. V2, so this is V1, let's say V1, this is V2, this is west 10 degrees south. Okay, so the curve is kind of going, I don't know, something like that. That's a terrible curve, but anyways, the car is coming down this way, and it curves and it leaves going this way. It's not a very steep corner. This V1 then, let's clean this up just a bit. This V1 here is 27 meters per second. Over here, V2 is 31 meters per second. All right, so we enter the corner going this fast, we leave the corner going this fast. What we're gonna do, kind of like we would do with projectile motion, is we're gonna break everything up into their components. Okay, if this is V1, there's the angle. This is gonna be V1 in the x direction. You can kind of think of cosine of 25 as adjacent over hypotenuse. So this is going to be 27 cosine of 25. And for V1y, you could say sine of 25 is opposite over hypotenuse. So this guy is going to have the sine for opposite over hypotenuse. So 27 sine 25. Some people like to stick with everything and just leave it like that, rather than round at all. So if you like more exact answers, I guess, you could just stick with this value and this value and carry on for whenever we sub those numbers in. This number, though, if you punch it in your calculator, it's approximately 27.47 meters per second. That is south, just kind of as a reminder. Again, if you prefer to use the more exact number, you can stick with that. I'm good either way. This one is west. Whoops, and this is the y direction. Here I am spouting off totally wrong stuff. Okay, so y direction always vertical, x direction always horizontal. Okay, so the y direction is this side, x direction is this side. Same idea with this one over here. We've got a triangle kind of going like this. This would be, again, x direction. I got to make sure I get this right. Whoops, this is V2x. This would be V2y. In the x direction, then, this would be, here, let's do this. Let's say V2x would be 31 cos 10 degrees. And again, as a number, that's about 30.529 meters per second. This one is also west. V2y, let's see if we can squeeze a pinch more information in over here. V2y would be opposite, so it's sine, so this would be 31 sine 10. V2y 5.383 meters per second. This is south. That one's west. Okay. So we do all of this work just to figure out the components. This is just good old-fashioned component type stuff, like if you're going to do component method. Where it's different from component method is what we're doing when we do this, we're trying to find out acceleration, average acceleration. Acceleration, we know, is V2 minus V1 over time. In this case, I'm going to look in the x direction and I'm going to look in the y direction. I'm going to treat those two separately. Okay, so AY v2y minus v1y over time. Okay, and we're going to kind of stick a line here. Again, kind of like projectile motion where we look in the x direction, look in the y direction. We're just going to use the same equation twice. What we're trying to do is not find this and not find this, but find those two pieces and then put them together to find the actual acceleration. So let me show you what I mean. Acceleration in the x direction then. v2x, I should choose some positive directions. Let's see. All the x stuff happens in the west direction, so let's say that's positive. All the south stuff happens, all the y stuff happens in the south direction, that'll be positive. So there's my directions, that's important. West is positive, so any of my west numbers are going in as positive, so 30.529, take away 11.41, and divide by 7 seconds. That 7 seconds is right there, that's just given in the question. We crunch those numbers and you come up with 2.731 meters per second squared. The answer is in whatever direction we said was our positive direction. Again, if rather than using these numbers, if you wanted to use those kind of exact values and key it in, you might get a slightly different answer. It is a little bit more exact, so if you feel more comfortable doing that, that's great. If you feel more comfortable just subbing in numbers, that's great as well. Keep a couple extra decimals though as you do it. In the y direction, v2y, south again is positive, so this is positive. v1y, 24.47. 7 seconds goes on the bottom. Acceleration in the y direction. Right, now this top part here is going to give me a negative. Okay, so I'm going to get negative. And just as a reminder, the first thing that comes out of here is in your positive direction. What that means is my AY is actually the opposite direction. It's actually north. Okay, so negative south means positive north. Okay, so this isn't my answer, but I need that number. I also need this number. And let's just look at this for a sec. This one kind of makes sense maybe intuitively. If you look just at the x direction information, I started off going about 11 meters per second west. I end up going 30 meters per second west. That makes sense. I accelerated west. Sometimes this one seems weird. I'm never going north in here, but I'm accelerating north. If you look at the numbers, I start off going about 24 meters per second south, but I end up only going 5 meters per second south. Okay, so I start fast, I end slow in the south direction. That means I'm slowing down, which means I'm accelerating north. Okay, so this does make sense if you think of it that way. Once we've got these things, again, kind of like in projectile motion or maybe in component method, if you get an answer that's a vector, you get x and y direction, we're just gonna redraw this. So we're going in the west direction here, we're going in the north direction here. So 2.727, 2.731. What we're looking for then is this side, acceleration. Don't forget, we always need an angle when we're talking about vectors. So this is just simple Pythagoras and trig now. Acceleration is 2.731 squared. This is squared, so kind of like c squared is a squared plus b squared, but hypotenuse squared is the legs squared, some of the legs squared. Don't forget we got to square root both sides. So add this up, square root both sides, we're going to get 3.859 meters per second squared. I also need to find this angle. Tan theta is opposite over adjacent, so 2.727 over 2.731. That's got to be pretty close to 45 degrees. Yeah, I just wrote down 45. The two sides are basically the same. This is basically an isosceles triangle. Acceleration then, let's go for sig digs. So 2 sig digs, 2 sig digs, 2 sig digs. We're keeping 2. So this is approximately 3.9. Okay, so we're rounding this number here. We're chopping it there, rounding to 3.9. And we're saying it's west. That angle is 45. And north. And there is our actual answer. But 2 boxes for the final answer. These were just numbers we needed. And that's acceleration in 2D.